Good morning, everybody. We are in the home stretch. You only have a few more assignments left. So when you get the opportunity, make sure to look in that remote learning category on Infinite Campus for this class. And make sure however many points you have, it's going to be out of 300. So make sure that you're doing enough assignments to get that passing grade, and that you're following along with this stuff as much as you possibly can. Don't be scared to stop in for office hours and ask questions. It's definitely going to pay off for you down the road when you go to take Algebra 2, okay? All right, what I would like you to do is try this warm-up. It's going to connect to what I'm teaching you guys today, so go ahead and pause the video and give it a try. When you are ready, unpause and I'll show you my answers. All right, so simplifying 24 divided by 30 simplifies into 4/5. And the reason is, right, if you think back to how fractions worked before, both top and bottom divide by 6, allowing us to reduce it. So keep that in the back of your head as we're going through these. All right, 120 over 200, they both at least divide by 10, so it's 12 over 20. And then both those can be cut in half, and then actually cut in half again until we get to 3/5. So it's also possible, sometimes you know exactly what you need to divide by to get the final answer. Sometimes you start dividing and you have to keep going until you get to the most simplified version. Again, that'll connect here in a little bit. 108 divided by 144 reduces down to 3/4, okay, because they both divide by 36. Again, you might not see that right away and go, oh, well, they're both evens. I can divide them both by 2 and maybe start there. All right, which expression is equivalent to this one? So up here in the top, -3 times 4 is -12, and x to the second and x to the fifth combine to give me x to the seventh. However, we can reduce that a little bit. If I have 7 x's on the top and 6 x's on the bottom, there's just going to be 1 left over on the top. And 12 over 9 reduces to 4/3. I'll keep the negative with the 4. So really, this one doesn't work. This one doesn't work. This one's close, but x needs to be on the top. So we're going to go with this one. Notice how even though we wrote it a little bit differently, it's still the same exact thing. All right, last one, number 3. 16 over 8 reduces to a nice neat 2, so there's just a 2 on the top. If you want to put a 1 on the bottom as a placeholder, you can. If there's 2 C's on top and 3 C's on bottom, 2 of them will cancel, so there'll be 1 C left over in the bottom. And if there's 4 B's on top and 1 B on the bottom, 1 B will cancel, so there's 3 B's left on the top. So the one that matches the most is letter F right here. So this is all prior knowledge, right? How to simplify fractions, how to simplify using exponent properties, things like that. That's going to come into play today because we're going to talk about rational expressions. Notice how they kind of look like fractions, but they have letters in either both the top and the bottom, or at least the bottom part of the fraction. So state the excluded values. Excluded values just means when you have a fraction, what's literally the only thing that can't happen in a fraction? You can't have a 0 on the bottom, okay? You can never do 4 divided by 0. That gets you undefined. It's not a thing. So when it says state the excluded values, you're basically saying what value for that variable would make the bottom a 0. So what we do is we set it equal to 0 and solve so that we can try to figure out, well, what 2 values are the only ones that aren't going to work? So the best way to solve these is to factor. So this looks like a difference of squares for this first example. So I'm going to make it r minus 6 and r plus 6. So my 2 excluded values are 6 and -6. So kind of connecting to solving, but saying, hey, if I plug in either 6 or -6 for r, that is going to be an undefinable expression because it'll be a 0 on the bottom. Same thing for this example over here. I can factor it, so n plus 5 and n minus 1. Remember, it's almost like, it's kind of like you're ignoring the top. Like, we don't really care what's going on in the top as of right now. We're only looking at the bottom. So my 2 excluded values would be -5 and +1. Go ahead and pause the video and try these 2 practice problems you see right below, and then unpause it when you're ready to see the answers. All right, so for this one factors into let's see, 2 and 4. So my 2 excluded values are -2 and -4. For this one, it factors, it's a difference of squares again, so x minus 9 and x plus 9. So my 2 values are 9 and -9. Awesome, so far so good. Now, what if they want you to find the zeros? Well, remember, zeros are the same things as x-intercepts. And x-intercepts are a number, comma, 0, right? So that means we need to plug in 0 for y. So in this case, it's not y, it's f of x. But we now have the understanding that they're essentially the same thing. And I say, okay, now I need to solve this. Well, that's kind of a weird one to solve, right? But what we could do to both sides is we could essentially multiply both sides by x minus 3. And x minus 3 times 0 is just 0. And on the right side, when I multiply, I'm just left with this top portion right here. So essentially, when you're finding zeros or x-intercepts, now you're only focused on the top part of the rational fraction. So then we solve it by factoring if at all possible. Positive 6 and negative 3 would be my factors. So my solutions would be negative 6 and positive 3. But because we don't want solutions, we want zeros, I'm going to write them as x-intercepts. So I'm staying consistent with what they're asking me to find. Go ahead and practice this one down at the bottom. Pause the video when you are ready and then unpause it to see the final answer. All right, so for this one, again, if I want to find the zeros, I plug in 0 for y, excuse me. And essentially, it's like you're multiplying both sides by x plus 1. So x plus 1 times 0 is just 0. And when I multiply this right expression by x plus 1, the x plus 1's cancel, and all I'm left with is the top. Let's factor if we can, which it does work. We can use 5 and negative 3. So I get answers of negative 5 and positive 3, but again, they wanted x-intercepts, so I'm going to write them as x-intercepts just to stay consistent. All right, you guys, that should give you enough to be able to work through some of these problems. One thing I want you to keep in mind is you can simplify things. So for example, where was I at? Okay, these guys, there's going to be a few questions on your homework that are kind of like that, okay? But the other thing I want to show you just super fast is there might be some ways to simplify that involve factoring. So remember how we talked about, okay, if you have x squared over x, that just turns into x because it's kind of like you're writing it out like this and you say, okay, one of them could go away, right? The same idea works with factoring. So let's say you have this expression and you go to factor the top and the bottom. And let's say, I don't know, you get something like this after you factor it. These two factors can go away, allowing you to just have x minus 1 left over. So the step before it might have looked like, let me double distribute this real quick. X minus 1. So maybe this is the original question on your homework, and it will say simplify as much as possible. Factor both the top and the bottom if possible, and if something cancels, that's the only other type of problem you might see as well. Okay, kind of the same idea as exponentials, but now we're connecting it into quadratics and factoring and how those pieces work as well. So give this homework assignment a try. It is going to be posted today, and then you'll have tomorrow to finish it. So stop by for office hours if you need some help.